Hello friends, here in the black box where we had such a good discussion today, but we'll talk about the unit circle now. I'm looking at, well, the unit circle, any trig on any place in the plane. If we've got any generic point x, y, like we're looking at here, then this distance is x, this distance is y, obviously. We've got that, and now we've got a couple of trig definitions. As you're looking at the triangle, the cosine of theta is x over r. You could also write that as x equals r times the cosine of theta, if you multiply both sides by r. The sine of theta, as you can see, is y over r, the opposite over the adjacent. So that's y equals r times the sine of theta. We're good here. The tangent of theta is opposite over adjacent. That's y over x, which is also the slope of that line. And so that's going to come in handy. Any point anywhere on the coordinate plane, these definitions work out. The cosine is the x-coordinate over the distance, the radius, and likewise x is r times the cosine. Similar for sine and tangent. If you're having issues with it, x comes before y in the alphabet, and sine comes before cosine in the alphabet. If we're on the unit circle, we're talking about a point xy. Unit circle has a radius of 1. X, 1, and y. So, like we had before, the cosine of theta is x over 1. Over 1 is a remarkably easy thing. There's no need to even do over 1. The cosine of theta on the unit circle is just x. Likewise, the sine of theta on the unit circle of radius 1, it's y over the radius, it's y over 1, which is the same as y. Tangent is still the tangent. Tangent of theta is y over x, which is the slope. Again, cosine of theta on a unit circle, radius 1, is just the x-coordinate. Sine of theta is the y-coordinate. And that can go either way. If you know the x-coordinate, you know the cosine. If you know the cosine, then you know the x-coordinate. And likewise. And again, alphabetical. Cosine comes before sine, x comes before y. Life is good that way. Good. One little sideline that we'll maybe touch on, maybe not. As you know, the equation of this unit circle is x squared plus y squared is the radius squared, so that's 1, which also means that for any function, cosine of theta squared plus the sine of theta squared is 1. Whoa, that's remarkable. That's totally crazy. That's a big topic for next year, but we've got it now. You know where you're at. So, using these definitions, cosine of theta is x, sine of theta is y, and the tangent of theta is y over x, or the slope. We can do these. 90 degrees, as you know, takes you to this point here. That's your 90-degree angle. The sine of 90 is the y-coordinate. Sine of 90 is 1. The cosine is the x-coordinate. It's 0. The tangent is y over x, or sine over cosine. 1 over 0, which is undefined, which is also the slope of that line. If you picture that line, the slope is undefined. Whoa! 180 degrees. That takes you to here. The sine of 180 degrees is the y-coordinate. 0, the cosine of 180 is the x-coordinate. 1, the tangent of 180 is y over x. 0 over 1, which is 0, which is, guess what? It's the slope of that line. Take 30 seconds here, pause the video, see if you can figure out what cosine of 270, sine of 360, and cosine of 720 are. We'll come back. Yay, we're back. Hope you did a great job with that. These are going to be good. 270 degrees is here. Ooh, I didn't label the 180, but this is 270. 270 is there. 180 is here. 270 is here, and the cosine is the x-coordinate. So we're talking about this point, and we're talking about its x-coordinate. The cosine of 270 is 0. You can verify all these on your calculator if you want. The sine of 360. 360, that's good color. 360 gets you here. That's pretty cool. This coordinate, that point, the sine is the y-coordinate, so the sine of 360 is 0. And last but not least, the cosine of 720 degrees. Oh, we need some good fun color for that. 720 twice around to here. And the cosine is the x-coordinate. Cosine is 1. Good work. Those are nice on the axes. Can we do or not on the axes? Guess what? We can! Life is good. Show a point on a unit circle corresponding to 82 degrees and give its coordinates. This is going to be good. 82 degrees is pretty easy. Yeah, I'll go back to the orange. 82 degrees is a little less than 90 degrees. 82 degrees. Its coordinates are very simple. Cosine and sine. Hello, here's my tools. Trig. What's the cosine of 82 degrees? I'm going to put a decimal place in so I get a decimal answer. What's the sine of 82 degrees? So the cosine, the x-coordinate, is 0.139. The sine, the y-coordinate, is 0.990. There we go. It's awesome. 0.139 and 0.990, and if you look at it, that makes a lot of sense because it's close to 0, 1. The x-coordinate should be small, the y-coordinate should be close to 1. There it is. The corresponding points in the other 3 quadrants without doing calculations. Oh my goodness. How can we do that? That's not bad. As you know, this quadrant will be 180 degrees minus theta. This quadrant will be 180 degrees plus theta. You have this already. You remember this from before. This quadrant will be 360 degrees minus theta. So the angles are going to be 180 minus 82. Well, that's easy. 180 minus 80 is 100 minus 2 more is 98 degrees. 180 plus 82 is going to be 262 degrees. And 360 minus 82 is going to be, well, 360 minus 80 is 280 minus another 2 is 278 degrees. So those are the angles. The coordinates are likewise very easy. You're talking about plus or minus the numbers that you already know. This one will be positive x, if you look at where it is, and negative y, negative 0.990. Down here in the third quadrant, they're both negative. Negative 0.139, negative 0.990. And likewise, up in this quadrant, x is negative, negative 0.139, y is positive, 0.990. There we go. Awesomeness. Take yourself a minute, pause the video. Try this one. See how it's going. 170 degrees. This one is in the second quadrant, but it's pretty cool, so we'll figure that out. Hey, welcome back. You've done it. You've been awesome. 170 degrees is here. A little less than 180. Let's find the coordinates. Hello, calculator. Please tell me the cosine of 170 degrees. Negative 0.985. And please tell me the sine of 170 degrees. Positive 0.174. 0.985, 0.174. Neg 0.985, positive 0.174. You look at this and you say, this makes sense again. The x-coordinate should be negative, and it should be close to negative 1. The y-coordinate should be positive, and it should be a little bigger than 0. So there we go. Positive but still close to 0. How do we put this in into the other quadrants, though? Well, this is 180 minus theta. 180 minus what gives you 170 degrees? That's right, you got it, Brooklyn. This is 10 degrees. 180 minus 10 gives you 170. So that's that angle, and the coordinates, 0.985, 0.174. Third quadrant, it's 180 plus theta. My theta was 10 degrees. I figured that out first, so this is 190 degrees. They're both negative. Negative 0.985, negative 0.174, and the fourth quadrant, 360 minus theta is going to be 350 degrees, and we are at positive 0.985 and negative 0.174. Yay! We're doing good. I know this video is getting long. It's all right. We broke it up. We're doing okay. Next slide, I think is the last one. Go in the other direction. Can we go the other direction? Pretty good. I'm going to do, oh, look at that. The red one is exactly the same one we just did. Silly me. Well, we'll work that one out. Let's do it the other way. Let's do the red one first. We'll do part B, and then you can do part A on your own, and we'll come back and see the answer. So part B. So in this case, I know X is negative 0.985. Y is 0.174. Pro tip is use the positive versions of those and then move them to the second quadrant if we need to move them to the second quadrant. So the question is, what angle gives you a cosine of 0.985 and a sine of 0.174? Our trusty calculator. If we're looking for the angle, you remember, this is an inverse function. Inverse cosine of 0.985. Remember I said we're going to use the positive version and then convert it as we need to. That says that's about 9.9 degrees. We're thinking maybe like 10. Inverse sine of 0.174 says 10.02. These two pieces of information together tell me this is probably a 10-degree angle. It's rounded off. So, inverse cosine of 0.985 is about 10 degrees. Inverse sine of 0.174 is about 10 degrees. We believe those are 10 degrees, and to the second quadrant, we do 180 minus 10, as you know, that's 170 degrees. So this is a 170-degree angle, which we remembered because we had that same question on the last page, but still yes. All right, take a minute, figure out what angle A is by doing your inverse cosine and your inverse sine, and we'll check. Welcome back. Here we are, inverse cosine and inverse sine. I hope that you took them and you did. Oh, I better look at what the numbers are. 0.438 and 0.899. The inverse cosine of 0.438 says about 64 degrees, and the inverse sine of 0.899 likewise says about 64 degrees. We're in good shape. Everything agrees. Inverse cosine of 0.438 was 64.02 degrees. The inverse sine of 0.899 was likewise 64.02 degrees, so we're going to call that a 64-degree angle. There you are. You've got this. We can do this unit circle trigonometry. Life is good. I hope that you had a good day in class, and I hope that you have a lovely afternoon.